Hello, everyone, and welcome back to our continuation of this discussion about degrees and radians. In here, we're just going to have some examples on how to convert a given angle in degrees to radians and vice versa. So, let's have a short recall. If you're going to convert a given degree to a radian, always use this one, pi all over 180 degrees radian. All right? So if you have a given angle that is in degrees and you want to convert it to radians, so you're going to use this one, right? Multiply the given angle with this one. Now, if you're going to convert a given radian to degrees, then you're going to use this one, 180 degrees all over pi, all right? Wait. Let me just fix that. There you go. So here, if you're going to convert a given angle that is in radians, just multiply it with this one. All right? So let's have some examples. Let me just erase this one, right? Okay. So let's start with this one. Suppose you want to convert, let's just say 30 degrees. Now, convert this one to radians. So again, if you have a given angle that is in degrees, you're going to use this one so that it would be converted to radian. So we will multiply it with pi all over 180 degrees radian. So here, we can simplify this given expression. 30 degrees and 180 degrees, they are both divisible by 30 degrees. 30 degrees divided by 30 degrees is 1 degree. And 180 degrees divided by 30 degrees is 6 degrees. So we have 1 degree times pi all over 6 degrees radian. All right? So here, multiplying them together will give you pi all over 6 radian. All right? Usually, they don't actually include this unit of radian. Right? As long as they have this number, they convert it into radian, then that's it. But for me, I would normally include radian because this is to avoid confusion. All right. So why is it that there's a chance that it will lead to confusion or complication? Suppose that you did not include radian here. What can you interpret this one? So first and foremost, what type of measurement of angle is this? Well, for us, we already knew that this is in radian, right? But how about to those who don't understand? All right, that's the first reason. And second reason is that there will be no representation or label to the final answer. All right, because if that's the case, maybe we're just going to put units instead of radians, which is actually wrong. So we need a representation or label for that answer, which is radian. All right, let me just erase this one. There you go. So now let's continue. We have negative 180 degrees. All right. So here, the same thing, we're just going to multiply the given angle with this one. So we have pi all over 180 degrees radian. Since we have the numerical value of 180 degrees on the top and on the bottom, we can actually cancel this one out. Cancel these two, we will have negative 1 degree and 1 degree here. So we have negative 1 degree times pi all over 1 degree radian. Hence, you have negative pi radian. That's it. Now, we will have the last example, which is 400 degrees. Now, you may be thinking, is it possible to have an angle that is greater than 360 degrees? Overall, in one in one rotation, forgive me, it is actually in 360 degrees. All right? Just like this one, if this is the terminal, this is the initial side, and your terminal side rotates counterclockwise or clockwise, then it rotates in one whole rotation or one whole complete rotation in which it reaches to the initial side. This is actually 360 degrees, right? Because one whole rotation is 360 degrees. So why is it that we have 400 degrees, all right? It's not that because why it existed, rather because it is possible that the angle greater than 360 degrees is possible to exist, right? So that means we can have 1000 degrees. And similarly to the negative value, let's just say negative 360 degrees, there's a chance that the angle will be less than negative 360 degrees, like negative 500 degrees, negative 999 degrees, so on and so forth. But for now, let's focus more on converting. We will discuss that later on, all right? So let's go back here. So let's convert 400 degrees. So we will use the same technique. There you go. So here we can simplify. I'm going to simplify this one slowly so that I won't be, how should I say this? I won't be, make mistakes, basically. I won't be making mistakes. So here I can simplify these two numbers by 10 or by dividing them by 10. All right. So 400 degrees divided by 10 is just 40 degrees. And 118 degrees divided by 10 is just 18 degrees. So as you can see, it just like we just remove 1 0 here, you know. So we have 14, 18. So here we have 40 degrees times pi all over 18 degrees radian. So here we can simplify 14, 18 degrees. So these two, they are both divisible by 2. So 40 degrees divided by 2, you will have 20 degrees. And 18 degrees divided by 2 is 9 degrees. So here we will have 20 degrees times pi all over 9 degrees radian. So we can have our final answer. Once we multiply them together, we will have 20 pi all over 9 radian. So that is our final answer. So 400 degrees is just the same as 20 pi all over 9 radian. So overall, by converting a given angle in a degree to radians, you're just going to multiply that given angle with this one. Now let's go convert from radians to degrees. This one. So remember, if you're going to convert a angle that is in radians to degrees, we will going to multiply that given radian with 180 degrees all over pi. So let's have an example. Let's just say we have 3 halves of pi or 3 pi all over 2. They're just the same, all right? Now let's convert it into degrees. So here, we're going to multiply it with 180 degrees all over pi. So here we have pi's on both sides, to be particular, from the top and from the bottom, so we can cancel it out. Then, the next thing here is that, oh wait, by the way, when you're going to cancel two the same term, this would be just 1, all right? All right, next, we're going to simplify 2 and 180 degrees because these two are both divisible by 2. So 2 divided by 2 is 1, and 100 degrees, 180 degrees divided by 2 is 90 degrees. So we have 3 times 1 all over 1 times 90 degrees all over 1. So multiplying them together, we will have the result of 270 degrees. See, that's easy. Now next, let's just say we have negative 4 pi all over 3, right? So here, we will do the same thing. We will multiply it by 180 degrees all over pi. So as usual, we're going to cancel the pi's here, which will give us 1 on both sides. And we're going to, sorry, and we're going to simplify 3 and 180 degrees by dividing them by 3, because both of them are divisible by 3. So 3 divided by 3 is 1. And 180 degrees divided by 3 is 60 degrees. Am I right? Just making sure. All right, I'm correct. So with that, we will have negative 4 times 1 all over 1 times 60 degrees all over 1. So multiplying them together, we will have the result of negative 240 degrees. That's it. That is our final answer. Now, last but not the least, let's try to convert 4 pi. So by converting 4 pi to a given degrees, we will have this one. 4 pi times 180 degrees all over pi. So we're going to cancel the pi's, which we will have 1 as a result. So here, we're just going to have 4 times 1 times 180 degrees all over 1. So multiply them, we will have the answer of 720 degrees. So that's it. That's basically how you convert a given uh, given radian to degrees. All right. So now I hope you got the idea on how would you convert a given angle in degrees to radians, and how would you convert a given angle in radians to degrees. All right. So with that being said, I'm just gonna end this video and we can now proceed to the next discussion. See you soon.